Hi, I'm Jeremy Veldman. Welcome to the July 2020 meeting of the Memphis Astronomical Society. Got a great program for you tonight, got a lot of material to cover, but before we do, just a few preliminaries. First of all, if you haven't already, please say hi in the chat room. Let me know how my audio is. Give me the thumbs up, the thumbs down. We are broadcasting live. Want to make sure you can hear me all right. And if you have any questions or comments throughout the course of tonight's program, please feel free to leave them in the chat room, in the chat window. We'd love to hear your feedback. Want to welcome everybody around the country and possibly around the world. Hope you're doing well, staying safe and healthy as we continue to ride out these unprecedented times. Now, July 2020 is an iconic month for the exploration of the red planet, and we'll get into that in a second. But before we do, we've got just a few preliminaries. First of all, our website is memphisastro.org. So if you want to learn more about us, go there. We're also on Facebook and Twitter. And if you haven't already, take a minute to subscribe to this YouTube channel. Now, our website has some great information on it, including links in the upper left to information on telescopes and a calendar of events. Now, this month, July 2020, like the last several, were temporarily postponed because of COVID-19. Not sure it really matters much for our observing sessions, as of the last six, 5 of the 6 have been clouded out. And the one that we did actually hold last month was a members only social distancing style observing session where we had 2 people show up, and we were only out for a couple of hours before we were clouded out and dewed out. So weather seems to be intervening as much or more than a global pandemic in these times, but eventually we'll get back out there. If you're on our email list, just continue to monitor any emails from us daily and weekly, and we are continuing to discuss the best way to open things back up in a socially distancing type format where we can do this safe. And if you're watching the news, you know that COVID-19 is still there. The numbers are spiking, and in this region also, it's just wise and prudent to continue to be vigilant and take the necessary precautions to keep everybody safe. So that's what we're going to do. Just stay in touch with your email, and we will let you know if and when and how we will open things back up for our public observing sessions. Having said that, we do have this event coming up later this month, a virtual star party. Now, this is not one that M.A.S. is hosting, but we are a participant. And basically, it's spots throughout the state of Tennessee where an astronomer plugs into Zoom and actually shows you what he's looking at. One of our astronomers at the Memphis Astronomical Society will be participating in this. It's July the 24th from 8:30 until 10:30. We'll send out some more information on this later this month. But if you're interested, mark your calendars for July 24. We have a Tennessee virtual star party coming up. One way or another, we're going to continue. Now, if you'd like to join our email list and you're not on our list currently, go to joinmas.com, enter your name and email address, and we will send you emails, future correspondence about events, anything related to the Memphis Astronomical Society. So if you're not on our email list, go to joinmas.com, enter your name and your email address. And when you become a member, you get access to our newsletter, The Meteorite, which has some great content, including articles from some of our members, minutes from past board meetings, an astrophotography gallery, and the sky map for this month. So the newsletter has some really value-added content, and one of the perks of being a member, getting access to the Meteorite. And now for everyone tonight, we will have links to these 2 documents in the description below this video. So if you're interested in the July sky map, we'll have a link to the July sky map at the bottom, and also a link to our membership application. Now, if you're interested in becoming a member, just download it, print it out, fill it out, scan it, and then email it back to us at memphisastronomicalsociety@gmail.com. Or if you don't want to do that, just send us an email, and we will be happy to send you an electronic version of our membership where you can just type and fill it out and make it very seamless and very easy. So Again, we'll have links to these two documents in the description below at the end of tonight's presentation. Got a lot of material to cover tonight. Mars, of course, is just a fascinating place. You can just imagine standing on the red planet, seeing a scene like this, the red Martian dust due to the iron oxide, and then also the dust in the sky that makes it kind of this pinkish, reddish hue. Now, if I were standing on the surface of Mars like I am right now, similar to last month's Venus presentation, I wouldn't last very long. The atmospheric pressure on Mars is less than 1% of what it would be on Earth. No magnetic field, no breathable air. So for different reasons than why I would die on Venus, I would die instantly on Mars. However, we're not sending humans to Venus anytime soon. There is the possibility of a future human colony or exploration to Mars. I personally don't think it's going to come anytime soon, but it's not beyond the realm of possibility. However, tonight we're going to talk about what's happening this month and early next year with the 3 countries that are launching 3 exploration probes to Mars to further our knowledge of the red planet. And really 2020, this month, is kind of the first link in a much longer chain of future missions that are hopefully scheduled to actually retrieve samples from the red planet, bring them back to Earth, put them in our laboratories, and analyze the contents. Those are future missions later in this decade, 2026, 2028. So actually, if you're watching tonight in the year 2033, first of all, we hope that you're faring a lot better than we are. And secondly, you may already have samples of the Martian soil in your laboratory as a result of missions subsequent to the ones that are being launched this month. We'll get into that, but before we get started tonight, the first half of our program is going to be kind of a brief overview of Mars, the planet itself. It's a 20-minute presentation put on by Bryan and Keith, and then we'll get right into the second half of our program and talk about some of the discoveries of past explorations, as well as the future missions that are coming up. So sit back, relax. Some of you are watching on your TV at home with your feet up. Hope you stay awake. Got a lot of content to cover tonight. So join us as we take a journey to the red planet.
Good evening, everyone. Did you miss me? This is Bryan again, and I will be your trusted narrator as we take a journey a little bit closer to our neighborhood, as we take a look at our neighbor, Mars, the red planet. This presentation was compiled by Keith Latilis. Our solar system was formed about 4.6 billion years ago from a vast spinning cloud of gas and dust. And if you remember from the Stellar Odyssey presentation, this vast spinning cloud of gas and dust was the protoplanetary disk. This spinning material collapsed and began to form with a center making our sun, and the unused material forming out 8 planets. The planets orbit the sun in roughly the same plane and travel in the same direction, clockwise as seen from about our North Pole. The 4 planets closest to the sun, also known as the inner terrestrial or rocky planets, consist of Mercury, Venus, Earth, and the farthest of the 4, Mars. Last month, Richard Townley gave us a view of Venus. In that same vein tonight, we discuss Mars with its fascinating canyon system and volcanoes. During this presentation, we'll talk about 3 aspects of Mars: its characteristics, what our fascination is with Mars, and what past exploration has taken place on the planet. Now, future exploration, I'll leave that up to Jeremy and his following presentation. Mars is about 1/4 the size of Earth, with a diameter of 4,218 miles and a mass of 6.39 times 10 to the power 23 kilograms. And remember, that is a 1 with 23 zeros behind it. The Mars orbit is much more eccentric than Earth's, hence it varies with a difference of about 26 million miles between when it's closest and furthest away from the Sun. Compared to an Earth day, A full orbit around the Sun takes a bit less than 2 years, at about 687 days. Mars has two small moons, Phobos and Deimos. Phobos is the larger of the two at about 16 miles long and orbits 5.825 miles above the surface, while Deimos is about 10 miles long and orbits about 2.5 times away. The Phobos orbit takes about 7 hours and 39 minutes, which means that there are 3 sets of moonrises and sets every day. Deimos, the smaller but more distant moon, orbits in about 30 hours and 18 minutes, a few hours more than the Mars day. Like Earth, Mars has a tilt, about 25.2 degrees, and despite its limited atmosphere, experiences seasons just like Earth. It's theorized that the early planet during its early stages, its material differentiated to form a core and layers. The heavy material settled to the center while the lighter silicated material formed around the core, and other material formed the crust. Over time, the molten layers cooled and began to solidify from the surface inward. Speculation is that the core has probably cooled enough to become solid, but further exploration may prove otherwise. And if you look at the picture on the slide here, you can see the cutout of Mars, which is very similar to Earth. So you still have a metallic core, but it may have actually cooled down enough to become solid. And then you have silicate rock surrounding the core. And then you have lighter materials which form the surface of the planet itself. And if its core has become solid, it might not be spinning, so as a result, Mars may not have a magnetic field. Let's now talk about some of the major characteristics or features of Mars. The atmosphere, polar ice caps, volcanic plains, crater-covered southern region, Valles Marineris canyons, and the volcanoes of the Tharsis Bulge. The atmosphere of Mars, given the liberty to call it that, is composed of about 95.32% carbon dioxide, 2.6% molecular nitrogen, and 1.9% argon. There are also trace levels of oxygen, carbon monoxide, hydrogen, and water vapor. It is extremely thin and has a pressure of about roughly 0.088 psi, which is less than 1% of the Earth's atmospheric pressure. Because of this very thin atmosphere, it is impossible for the planet to sustain liquid water, at least at its surface. Although it is theorized that frozen water could be below the surface and under a frozen covering of CO2 of the polar ice caps. A side effect of this thin atmosphere and lack of water is the iron dust that covers everything and has given Mars its distinctive red color. Mars is subject to massive dust storms across the entire planet. Many are so large that they are observable by telescopes from Earth. Global dust storms occur on average every 5.5 Earth years, and have threatened the operations of Earth rovers, which recharge batteries by solar activity. So, if you thought that the Great Dust Bowl of the 1930s was bad, try going on Mars and having to deal with their dust bowls. It has also been discovered that the Martian atmosphere is losing mass into space on a continuous basis. Because of this thin atmosphere and greater distance from the Sun, Mars is cold. Very cold. Now let's move on to the polar ice caps. The planet has two permanent polar ice caps. Because of Mars' tilt, approximately 25 degrees, and its orbit is similar to Earth's, one pole lies in continuous darkness, lowering the temperature dramatically and causing some of its thin atmosphere to be frozen into slabs of carbon dioxide ice, possibly covering frozen water beneath. As the orbit continues, like Earth, Mars exhibits seasons, and as one pole comes into sunlight, some of the frozen carbon dioxide will actually melt. Now with the atmosphere and the polar ice caps out of the way, let's move on to some of the more interesting features of Mars. First we have the low-lying volcanic plains of the north, also known as the Vasistas Borealis. This is a vast region in the northerly latitudes of the planet. It's the largest lowland on Mars. The area was named by Eugene Antoniadi, who noted the distinct differences in his book La Planète Mars, which was published in 1930. The name was officially adopted by the International Astronomical Union in 1973. Some scientists hypothesized that the area could have been covered by an ocean at some point in Mars' history, with the shoreline suggested from ridges in its southern edges. Vasistas Borealis is very noticeably smoother than areas in the south of Mars, which give some credibility to this theory. So if you look very carefully, you can kind of see this plane because it's very distinguishable, because the dust itself looks lighter in color, and you can actually see edges when you look at the dark patches. So basically what they're saying is that this whole area could have been one giant ocean at some point in time before either all the water or all the liquid carbon dioxide or nitrogen that could have existed on the planet either solidified or evaporated off of the planet due to its thin atmosphere. But unlike the northern geography of Mars, the southern terrain is littered with craters, much like some areas of the Moon. Large, partially filled craters, small bowl-shaped craters, along with facetal craters. The largest impact basin of Mars is named Hellas. It's about 5 miles deep and about 4,350 miles across, which included an elevated ring surrounded the depression. Many of the craters in this region measure tens to hundreds of kilometers across and are highly eroded, unlike smaller craters on the other planes of Mars. For scientists, this offers a couple of potentials. One, that the lower section of Mars is actually older than the rest, or two, because of erosion rates that the climate on early Mars is much different from what it has become, possibly due to the loss of atmosphere and with it water. So you can think of the northern region as being more barren and more plain-like, while the southern region is more cratered filled and filled with hills, canyons, vast difference. Speaking of canyons, that leads us to the Valles Marineris Canyon System. Said to be the largest canyon system in the solar system, the Valles Marineris is a huge valley that extends over 1,800 miles and as much as 375 miles across and 5 miles deep, stretching over a quarter of the planet's surface. The Grand Canyon in Arizona, by contrast, is no more than 500 miles long and is only 18 miles across and just over a mile deep at its deepest. Keep in mind that Mars is only about 1/4 of the size of Earth. There are a number of theories as to why and how it formed. One popular hypothesis is that it started out as a crack billions of years ago as the planet cooled. Another theory is that the eastern flank of the rift, there appear to be channels that may have formed by water or carbon dioxide. Valles Marineris could also be a large channel formed by the erosion of lava flowing from the flanks of Pavinus Mons, one of Mars' largest volcanoes. While the Valles Marineris Canyon system is a distinguishing feature of Mars, so is the gigantic volcano Olympus Mons. The same internal forces that form the canyon system also formed a raised area known as a Thalsis Bulge. The Thalsis Bulge is the home for 3 giant shield volcanoes, one of those being the before-mentioned Olympus Mons. The caldera on the summit of the volcano is surrounded by ancient lava flows. This monstrous volcano stands 13 miles high and is the largest and tallest volcano in the solar system. By comparison, the tallest known volcano on Earth is named Mauna Kea, which is in Hawaii. It's mostly underwater and only has a height of about 33,500 feet, which is no more than 6 miles. In fact, Olympus Mons is so tall that if you just excuse this computed diagram of it, you can actually see it from space. Our fascination with Mars. Earthlings' captivation with Mars began centuries ago. The Babylonians have the first records for planet names. Babylon's patron god was Marduk, and was recognized in Babylonian astrology as the planet Jupiter. But the Babylonians believed in many gods, all with different purposes, and certain gods were associated with planets. The Babylonians called Mars Nergal, the great hero and the king of conflicts. The Egyptians were the first astronomers to note that the stars seemed fixed, and that it was the sun that moves relative to the stars. They noted the 5 bright objects that seemed to move in a similar manner. These were later named Mercury, Mars, Venus, Jupiter, and Saturn. They called Mars Haardekker, the red one. It was the Romans from where the name comes from. In Roman religion, Mars was a very important god. His role was second only to Jupiter, the leader of the pantheon. Mars was the son of the god Jupiter and the goddess Juno. His father, Jupiter, was the god of the sky and thunder. Jupiter was considered the chief or central guardian of Rome, and was often considered to be witness to solemn oaths, such as those undertaken by government officials or soldiers. His mother, Juno, was a protector of Roman women and was a patron goddess of Rome. Both his mother and father were known for strength and protection. Mars himself was a god of war and was himself seen as protector of the Roman army. He was thought to be difficult, argumentative, and unpopular among the gods, but was revered by men, especially soldiers. It was even reported that Mars was the father of Romulus and Remus, the twin brothers who were the founders of Rome. Since he was known as a war god, it was easy to make the connection to the blood of war and the planet's color of red. By the time of the late 19th and 20th centuries, possibly due to poor telescope optics, it was erroneously postulated that there were canals on Mars. One of the first recorded reports was from the Italian astronomer Giovanni Schiaparelli during the opposition of 1877. Schiaparelli called these lines canali. Later translated into English, it should have been channels, but rather translated as canals. In the 1900, Percival Lowell began making sketches of Mars, showing the Martian surface crisscrossed with lines connecting larger sections. Where some of these lines intersected, there was a circular blob included. These days, there is speculation that it wasn't necessarily an optical illusion, but that what Lowell was recording may have been wishful thinking, possibly influenced by Schiaparelli. Regardless, these drawings found themselves accepted as reality. As the old tale of the emperor's new clothes, others at the time seemed to jump onto the bandwagon, and the theory of canals being used for irrigation seemed to gather support. So much so that the fiction writer Edgar Rice Burroughs took great liberties in his early 20th century series of novels set on Mars. Even though there was no direct evidence of life being on Mars, Burroughs' stories created the Martian myth that permeated the human psyche. As astronomical observations and optics improved, they revealed that the canals to be most likely an optical illusion, and with high-resolution mapping of the Martian surface by spacecraft, shows no such features were present. The Martians are coming. The Martians are coming. And don't forget the Orson Welles 1938, a young actor who enacted the radio adaptation of H.G. Wells' War of the Worlds, where Martians invaded Earth. It was broadcast from the Mercury Theater on Sunday, October 30th, which is Halloween night. The episode was so believable, it caused panic among its listening audience, and the opening broadcast announcement explaining that it was, in fact, an adaptation of the War of the Worlds. As a follow-up note to Percival Lowell, who pushed the idea of canals on Mars, Lowell, who is the same American businessman, author, mathematician, and astronomer who founded the Lowell observation in Flagstaff, Arkansas. He is credited for predicting the existence of a planet beyond the orbit of Neptune, which later initiated the search that ended with the discovery of Pluto 14 years after his death. The Lowell Observatory was also instrumental in working closely with NASA as they worked to put a man on the moon. And now we finally reached the missions to Mars. Let's talk about some of the early missions. The exploration of Mars has been an integral part of the space exploration missions of the Soviet Union, which later became Russia, the United States, Europe, and Japan. Dozens of unmanned spacecraft, including orbiters, landers, and rovers, have been launched towards Mars since the 1960s. These missions were aimed at gathering data and answering questions about the red planets and its past that may yield future insight into the Earth's past, present, and potential future. The Soviets, as usual, were the first ones. Unfortunately, the Soviet space program was plagued with difficulties. In 1962, they launched Mars 1, which was the first pair of probes for a flyby, and a lander for a surface landing. Neither were successful. Then in 1971, they attempted surface contact with probes Mars 2 on November 27th and Mars 3 on December 2nd. The Mars 2 failed during its ascent, and the Mars 3 probe failed about 20 seconds after the first Martian soft landing. Later, their Mars 6 probe also failed during the descent, but was able to return some corrupted atmospheric data in 1974. It was NASA which was credited with the first successful flyby on July 14th and 15th, 1965, with their Mariner 4 probe, and then the first to orbit a planet when it entered Mars orbit on November 14th, 1971. In 1975, NASA undertook the Viking program, which consisted of two orbiters. Each had a lander module that touched down successfully in 1976. The Viking 1 remained operational for 6 years, while the Viking 2 remained operational for 3 years. These provided the first color panoramas of the Martian surface. The Soviets returned with probes to Mars moons. The probes Phobos 1 and 2 were launched in 1988. Unfortunately, they were struck again with bad luck. The Phobos 1 lost contact on the way to Mars, while Phobos 2 successfully photographed Mars and Phobos, but failed in its mission to land when its two landers on the surface of the tiny moon. Discovering Mars had been difficult. Of the 55 missions sent prior to 2000 to study the planet, only 25 have been successful. But as technology improved, so does success. Since 2001, there have been 16 Mars missions, and of those, 12 have been successful. Although some missions met with failure, there have also been a number that have collected vast amount of data, helping us understand more about Mars. Based on time constraints, this presentation will only have a few of the most memorable missions. One such mission was NASA's Mars Global Surveyor. It achieved orbit in 1997 and completed its primary mission of mapping the surface in early 2001. but the craft continued to function, and in its third mission in November 2006, operating years in space, contact was finally lost. Another extraordinary mission was NASA's Mars Pathfinder, which carried a robotic exploration vehicle named Sojourner. Sojourner landed in the Ares Vallis area in the summer of 1997 and explored the surface for about 3 months. Even though the mission was scoped to last for 7 sols, Martian days, with a potential of 30 sols, it in fact lasted for 83 sols, or 85 Earth days. And if you look at the picture of the rover, if you remember, if you're over 30, this is the same rover that you saw on the cover of National Geographic Explorer that also had the 3D glasses and had the 3D pictures. Just a little side note. And finally, this leads us to NASA's Mars exploration rovers, Spirit and Opportunity. Considered one of NASA's most successful ventures, both rovers met and exceeded all of their scientific objectives and more. One incredible conclusion was evidence that liquid water existed at some time on Mars at both landing sites. Spirit was active from its landing in 2004 to 2010, when it became stuck in a sand dune and was unable to recharge its batteries. Opportunity, which landed 3 weeks after its twin Spirit, began its surface mission on July 25, 2004, with a planned mission of 90 sols, which is a little bit less than 93 Earth days. But this little rover could keep running. NASA worked the operation of the vehicle, hibernating during events such as dust storms to save power, and managed to exceed its operating plan by 14 years, 46 Earth days. The last contact with NASA was June 10, 2018. During its lifetime, the rover traveled a distance of approximately 28.06 miles, and spent over 2 years exploring the Victoria crater and reaching the Endeavour crater, another potential landing site. So if you look on the slide here, you can actually see where it started at. So it started at the Eagle crater, then but basically wheeled over at a slow pace over to the Endurance crater, then made it to Victoria, then took its long journey all the way over to the Endeavour crater. And it lasted 11 years and 2 months. Way to go. And those have been the current missions that we've had on Mars so far. Now, what's in the future? Well, I'll leave that up to Jeremy to tell you. As for right now, this is Bryan signing off. Thank you for attending this presentation.
Welcome back. That, of course, was Curiosity landing on Mars 8 years ago. Video animation from NASA. I'd encourage you to watch the entire video. It's on YouTube. It's fantastic. Now, the previous two rovers, Spirit and Opportunity, used airbags. Curiosity used a combination of a sky crane, parachute, and retro rockets. And the fact that NASA and JPL would even attempt this is incredible, let alone pull it off. Mars is the hardest planet in the solar system to land on because its atmosphere is just thick enough to burn up a spacecraft from frictional heating, but not thick enough where parachutes work alone. So you need a combination of parachutes and retro rockets all firing and timing at the exact time to land a spacecraft gently on the Martian surface. And the fact that NASA pulled this off 8 years ago with Curiosity is extraordinary. Now, shortly after Curiosity landed, in fact, I remember when this was announced at our August 2012 M.A.S. meeting, about a month later, this issue of Engineer was dropped on my desk, and it talks about the connection between research at UT Knoxville and the development of the Curiosity rover. And inside was a write-up on this man, Dr. Benjamin Blaylock, who was actually my thesis advisor at Mississippi State University, and development work that he did to develop a quad operational amplifier. It's a building block that's used multiple times on Curiosity. Now, a little background on me. After graduating from Christian Brothers University, I went to Mississippi State and studied VLSI, very large scale integration. Not a very good term, but it's a subset of electrical engineering that deals with the development of analog and digital integrated circuits. Microchips, integrated circuits. And turns out that, of course, microchips are everywhere now. There's billions of them that are being used to transmit tonight's presentation via the computer that you're watching on, the internet, the switches and routers that make up the internet, as well as your iPhone, wherever. Now, most of the microchips on planet Earth use what's called bulk CMOS, complementary metal oxide semiconductor. And it basically builds transistors by having a substrate and then etching wells into a substrate to build transistors. Transistors are the building blocks of all integrated circuits. There are billions of them on the chips that are used, again, in all of your electronic circuitry. Now, bulk CMOS works great on planet Earth, where you have the comfortable environment of a regulated temperature, a magnetic field, and an atmosphere that protects Earth, the surface of Earth, from cosmic rays and the solar wind. However, in outer space, turns out that chips that use bulk CMOS technology don't work as well. You have parasitic effects like latch up, which I won't get into, but it's something that we had to guard against when we were designing chips, as well as leakage and other things. So at Mississippi State, Ben Blaylock, my thesis advisor, was contracted with the Jet Propulsion Laboratories to explore alternative VLSI technologies to be used to develop primitive analog circuits that would eventually become the building blocks for larger chips and systems for future exploration rovers. At that time, it was Europa. They were fascinated by going to Europa, and now Mars. And here you can see, this is a snapshot of my master's thesis exploring two different types of VLSI technologies, bulk CMOS on the top and then SOI, silicon on insulator, on the bottom, where you isolate the transistors using a buried oxide layer. And so that was our research work. Turns out SOI works much better in outer space, where you have the harsh radiation environment on a planet like Mars or extreme temperature swings. Bulk CMOS, not so much, but it's very efficient bulk CMOS for chips on Earth. Now, I graduated, went into industry. About a year or two later, Ben returned to UT Knoxville. Of course, that's his alma mater. That's where he did his undergraduate work. He did his PhD work at Georgia Tech. And long story short, fast forward a little over a decade later, and you have the development of this chip right here, which is the quad operational amplifier. And a write-up of the work that his team did. Now, what's unique about this design is that it can function in the ambient environment on the surface of Mars without protection from something called the web or the warm electronic box. And thanks to extreme environment capable electronics, the Curiosity rover uses distributed system architecture in contrast to the centralized system architecture that was utilized in the previous two rovers, Spirit and Opportunity. And then the bulk of the electronics required for Spirit and Opportunity were housed within the web of those two rovers, requiring many long cables routed out to the ambient environment. The Curiosity has significantly more scientific instrumentation than Spirit and Opportunity. So the fact that it could utilize a chip like this that doesn't need the extra space and the extra mass of the web, but can actually function out in the ambient, basically frees up additional real estate on the rover that NASA can utilize to develop other technologies. So this was part of the innovation of the Curiosity rover, done by research at UT Knoxville at the time from my thesis advisor, Dr. Benjamin Blaylock, who's an expert in analog IC design. So that, in some small way, is my connection to the Curiosity rover. Great work. By the way, this is one of his PhD students who did work on this project as well. Another one of his PhD students, after doing work on this project, graduated, went and worked for Texas Instruments. And if you remember the device, that's a platform where you basically just set your cell phone on and it charges it up without any external cables. Well, it turns out that one of Ben's students developed the chipset at Texas Instruments that was implemented in that device. So that's oftentimes what happens. Students go to do research work at universities on projects like this for NASA, JPL, in aerospace, and then eventually graduate and go into industry and then develop technologies that become part of our everyday experience, consumer electronics. So this is part of the fallout, the innovation that eventually we all experience as a result of this type of work in the area of astrophysics and space exploration. So pretty cool stuff. If you're considering a career in microelectronics, that area of VLSI, you're not going to find a better thesis or PhD advisor than Ben Blaylock. Just a really terrific guy. And in many ways, this presentation is a tribute not only to him, but to all the other scientists and engineers around the world who do this type of work that may not necessarily be immediately recognized, but has a profound impact on our ability to explore other worlds. So here you can see a picture of the Curiosity rover taking a selfie in an area called Buckskin in Lower Mount Sharp. Now, Curiosity drilled this hole, it's about the size of a dime, and analyzed the contents. What makes Curiosity unique is it's not just a rover, but it's really a robotic geologist, if you will, roaming the surface of Mars, collecting samples, taking them inside of its belly, and then analyzing the contents. In fact, that's really what Curiosity is. It's Mars Science Laboratory. It literally is a roving Mars Science Laboratory. And Buckskin, when it analyzed the contents of this material, it discovered an unusual silica material called tridymite. Now, on Earth, tridymite is typically only found in environments with low pressure and extremely high temperatures, like you see in explosive silica-rich eruptions, volcanic eruptions. And it was not thought that these types of volcanoes existed on Mars, but after this sample was collected, it gave geologists more insight into Mars's warm and more dynamic and volatile and volcanic past, if you will. So pretty interesting discovery. Now here you can see a view of Gale Crater, which is where Curiosity landed. And Gale Crater is a crater that resulted from a giant impactor billions of years ago, once an ancient lake on Mars. And we can actually see where Curiosity landed and the areas where it traversed. You can see it was a clear day, and off in the distance, there's a hill outside the crater more than 50 miles away. If you traverse the rest, that's the edge of the canyon. There's Peace Vallis. That's actually an ancient riverbed, a channel of water flowing into the lake. And these are all mountains. These mountains are a mile high, and they form up the rim of the crater. And we can and Curiosity, when it took this panoramic picture, is actually showing you the path that it took from its landing site 8 years ago, then to Yellowknife Bay, and then it traversed along the edge of the crater. Darwin, Cooperstown, the Kimberley, some interesting discoveries there. Talk about that in a second. Along the the Naboom Dunes near the Bagnald site, and then it continued to traverse along the Murray Buttes, and then eventually the Irison Hill, and then it started to climb the edge of Vera Rubin mountain, where it took this panoramic view of the entire site where it landed. Here is another shot of Gale Crater from Curiosity. Very interesting geologic formations. I tell you, some of these pictures, if you didn't know better, you wouldn't know if you were standing on Mars or in some parts of the desert Southwest. Here's a selfie that Curiosity took on January 2018. Now, a SOL is a Martian day. It stands for Martian Solar Day. It's a little over 24 Earth hours. Martian day is about the same length of time as an Earth day. Naboom Dunes near the Bagnall Dune Field. Fascinating discovery. You can see here 2 sizes of wind-sculpted ripples are evident in this view of the Martian sand dune. The sand dunes of the smaller ripples also exist on Earth. The larger ripples are about 10 feet apart, and we don't see these types of sand dunes on Earth. So really a cool picture. Now this is the Murray Buttes outcrop, also part of the Curiosity exploration, near Stimson Formation. What you're seeing here are different layers of sedimentary rock that were formed through weathering processes, multiple weathering processes over time, either wind or water erosion. So the buttes and mesas rising above the surface in this area are eroded remnants of ancient sandstone that originated when winds deposited sand after lower Mount Sharp had formed. Curiosity closely examined that layer, it's called the Stimson Formation, during the first half of 2016 while crossing the Nakkuft Plateau between 2 exposures of the Murray Formation. So this again is clues into Mars's more dynamic past. Here you can see another image from the Curiosity mass cam. Clay, another thing that Curiosity discovered, clays. Where do clays form? Aqueous solutions like water. So very interesting. And then here's the view of Curiosity overlooking Mount Sharp. You see different colors of rock formations. So this is a composite image looking toward the higher regions of Mount Sharp on September 9, 2015. In the foreground, about 2 miles from the rover, is a long ridge teeming with hematite and iron oxide. Just beyond is an undulating plain rich in clay minerals. And just beyond that are a multitude of rounded buttes, all high in sulfate minerals. The changing mineralogy in these layers of Mount Sharp suggests a changing environment in early Mars, though all involve exposure to water billions of years ago. Further back in the image are striking light-toned cliffs in the rock that may have formed in drier times and now are heavily eroded by winds. The colors are adjusted. Of course, now the images that you're seeing here are adjusted so that the rock colors that we see on Mars match what we see on Earth. So this is not what it actually looks like. Of course, the sky on Mars is more pinkish due to the presence of iron oxide dust. So this looks very similar to what you would see on Earth, but that's so that geologists can compare the rock formations on Earth to the rock formations on Mars. Here's another pretty cool shot of the Curiosity rover tracks as it looks back. And a Martian sunset. This is where you really are looking at an alien sky. Now on Earth, most of our atmosphere is nitrogen, which scatters blue light. Mars has a very thin, mostly carbon dioxide atmosphere. So when the sun sets on Mars, more of the blue light comes through. On Earth, you see reds and oranges, longer wavelengths because of the thicker atmosphere and the blue light being scattered by the nitrogen. You don't see that on Mars. So this truly is an alien sunset when you see that light blue being filtering through. So really, really an amazing shot from Curiosity. And dust devils. Now the dust on Mars is lethal. We don't think about this. Mars has an axial tilt very similar to Earth. Earth is 23.5 degrees. Mars is about 25. So Mars has seasons just like Earth does. And the polar ice caps are made of carbon dioxide on Mars. So in summer months, when the northern hemisphere is tilted toward Mars, you have the carbon dioxide not melting but sublimating away, because it doesn't go to a liquid, it goes right from a solid to a gas, sublimates. And then of course you have the polar ice cap on the southern hemisphere freezing. So that creates a sink and a source, which is the weather is where you get your weather patterns on Mars. Not like on Earth where the water drives the east-west weather patterns for the jet stream. On Mars, it's the north-south polar ice caps shrinking and expanding due to the different seasons. And so you can get dust storms, planet-wide dust storms as a result, what we saw a couple years ago. And the dust is very fine, very thin. And one of the challenges that we're going to have if we ever send a human colony to Mars is dealing with the dust, because it gets everywhere. The dust grains are ragged, kind of like they are on the moon, and they can erode the fabric of a spacesuit. You have a very dry environment on Mars, so the dust particles can literally collide with each other and cause static electricity. You get lightning on Mars, but it's not like lightning on Earth. It's dry lightning on Mars. Static electricity as a result of colliding dust particles. And that can wreak havoc, again, on your electronic circuitry. And of course, if you send a probe to Mars, like Opportunity, that uses solar panels as its primary power source, you can run into a situation like this. You can see that after a dust storm, Opportunity was mostly covered, its solar panels, in dust, limiting the amount of sunlight that that the rover could receive and subsequently power its electronics. Fortunately, Opportunity was able to get out of this because another dust storm came and actually cleared off the solar panels, and it was able to recharge its batteries and go. So, amazing story. Richard did a presentation on Opportunity. I've asked him to redo it. We will post it to our YouTube channel. This is, Opportunity lasted, I think, for 14 years before it finally gave its last signal in 2018. But the fact that this rover was able to last as long as it did and then travel, I think, more than 15 miles along the Martian landscape is just absolutely incredible. Just an extraordinary story. But yeah, solar panels, really, dust can wreak havoc on solar panels for exploration probes to Mars. So the dust is lethal. Mars is not a nice place. Extreme environment, extreme temperature swings in the environment, very thin atmosphere with no breathable air, no magnetic field, so radiation from the sun in the center of our galaxy penetrates unimpeded, and then of course dust. So got a lot of challenges if we ever want to colonize Mars. Speaking of colonization, the idea of life on Mars is certainly not a new one. It's been in our subconscious as human beings seemingly for centuries. Really came to a head at the latter part of the 19th century, starting with Giovanni Schiaparelli, who observed features on the surface of Mars that he labeled as canali. Now again, Mars goes through seasons, so you can see, if you're looking at Mars from a distance through a telescope that maybe doesn't have the resolution of the telescopes that we have today, you can see surface changes as a result of weathering. Again, you may have a planet-wide dust storm like we did 2 years ago, which basically obscures the entire disk, makes it just an orange ball. Or you may have, darker and lighter features that change as a result of the weathering on Mars. Now, in the latter part of the 19th century, it wasn't exactly sure what was causing this. So it appeared as though Mars from a distance went through seasonal cycles like Earth did and had vegetation growth and retraction. So Schiaparelli observed some of these dynamic changes on Mars and labeled them as canali. Now, canali in Latin means channels, but canali in English sounds a lot like canals. So that sort of led to this idea that there were canals on Mars, and if you have canals, subsequently you have canal builders. Percival Lowell was an ardent believer of this, and he actually completed a detailed surface map, if you will, of canals on Mars. Lowell was obsessed with the idea of life on Mars. He basically stated that there was life on Mars, that there were canals being built by Martians to, I believe, extract water from the polar ice caps and bring them down to other parts of the surface. So Lowell devoted a large part of his career, really his life, to proving that canals existed on Mars. Now, what's fascinating about this story is why was he so convinced that Mars had these types of features? One of the reasons may be because he was using his telescope at an unusually high magnification, at high power, staring at the disk of Mars intently. And if you do that for long periods of time, just like if I stare at a light bulb for a long period of time, I can actually see, and then I blink my eyes, I can see the pattern of my own retina imprinted on my brain. So one of the possible theories for why Lowell was convinced that Mars looked like this was actually he was seeing an imprint of his own retina as a result of staring at Mars so intently at high power. Don't know, but kind of a fascinating story. And of course that led to books like War of the Worlds, H.G. Wells, 1898, this idea that Mars is a dying world that needs to invade our planet to extract its natural resources for survival. And fast forward 40 years later, you have this iconic moment in American culture, October 30, 1938, when Orson Welles, then a 23-year-old broadcaster on radio, put on a production of War of the Worlds, no relation to H.G. Wells. But at that time, 1938, we're in the middle of a depression. Storm clouds of war are surfacing in Europe, and people are more and more becoming anxious. It's not inconceivable that in the subconscious, people had this idea of invasion because it was happening in Europe already. Maybe it's going to happen here in the United States. And Orson Welles' broadcast of War of the Worlds was so convincing that it led to literally a countrywide panic. Just a fascinating story. So Mars, of course, is a cold, dry, dead world today, but we now have evidence, strong evidence, to suggest that in the distant past it was more Earth-like, that a large portion of the surface was water, covered in water. And we've seen that over the years. Here's an example of a picture that was taken by one of the Mars orbiters of the Ravi Vallis. Now what you're looking at is a portion of Mars's crust that has been traumatized in some ways and led to a large flow of water. Whether it's a volcanic eruption or a hit from a meteorite, it broke open the surface and released groundwater under high pressure. As the water escaped, it undermined the ground and caused it to collapse in a chaotic jumble. The floodwaters raced toward the right, eroding Ravi Vallis on the way. So the flood was strong that in this parts of Ravi Vallis. So large catastrophic flows of water on portions of Mars' surface. You see this here with Kessi Vallis also, could perform from a large outflow of water on Mars. Again, similar to what we see in the northwest of our country, in places like Montana and Idaho, the Scablands, where when the glaciers were receding 10,000 years ago, basically it backed up a large quantity of water, like a dam. And then when that ice burst, it's like a bursting dam that released a large flow of water into portions of eastern Washington, Oregon, Idaho, and Montana that eventually flowed into the Columbia River and out to sea. Those are called the Scablands in the United States. We see a similar phenomenon on Mars where we have a large flow of water from some source that was there for a short period of time and then vanished and formed these types of surface features. So that's one evidence for water on Mars. Now, Opportunity sampled this, hematite. These are iron oxide minerals that form in an aqueous solution like water. They're called blueberries. They're actually hematite. Now, there is some controversy about the source of blueberries, depending on their size and how uniform they are. Smaller blueberries may come from things like meteorites dissolving in the atmosphere. But when you see a structure like this, where it's not just spherules, individual spherules, but also a conglomerate, basically two or three that are melded together like this structure here, that's proof, essentially, of something that happened in the presence of water. So one of the discoveries from Opportunity was water on the surface of Mars. And then this, another discovery from Curiosity, near the Yellowknife Bay campaign, in areas called Link and Hoda. This is the presence of something called a sedimentary conglomerate and sandstones on Mars. These are evidence of moving water. The pebbles that make up, and you can see a comparison here between what we see on Mars and what we see on Earth, very similar. Wind is not strong enough to pick up pebbles over 1 centimeter in diameter and carry them along in the current. The pebbles in this rock show a high level of rounding, which implies a significant distance of transport. So this is clear evidence that they have been tumbled in fast-moving water about 10 to 100 centimeters deep. Ancient Martian hillside streams. Sedimentary conglomerate, another revolutionary breakthrough discovery, if you will, from the Curiosity campaign around Yellowknife. So we see multiple lines of evidence for the presence of water in the past on Mars. Here again, Kimberley Formation, a picture from Curiosity in 2015. These are sedimentary rocks in the Gale crater. Contains thick deposits of finely laminated mudstone that represent fine-grained sediments deposited in a standing body of water that persisted for a long period of time, long enough to allow sediments to accumulate in significant thickness. It's believed that the Gale crater, where Curiosity landed 8 years ago, 2012, was once an ancient lake that lasted for perhaps millions of years to allow these types of deposits to form. And here you can see more cross-bedding structure of sandstone, a picture taken from 2015 from the mast camera on Curiosity. It shows an outcrop of cross-bedding sandstone in the lower slope of Mars's Mount Sharp, very similar to the wind-blown sandstone outcrops that are commonly found in the United States Southwest. If you've ever been to Utah, the southern part of Utah or the northern part of Arizona, if you haven't been there, first of all, I highly recommend you go. It's an absolutely fantastic trip. But if you ever take a trip through the Vermilion Cliffs in northern Arizona or through the Glen Canyon region in southern Utah, you're going to see formations like this. In fact, Zion National Park, you'll see something similar to this also. This particular image was actually compared to a Navajo sandstone in Utah to compare the geological processes that formed each. So a lot of similarities between what we literally see from a geological perspective on Mars versus the desert Southwest on Earth. We have water, then we have the possibility for life. And this is what Mars 2020 is all about. Looking for the biosignatures. Life doesn't exist on Mars anymore, but everywhere we found water on Earth, we found life, even if it's primitive microbial life, bacteria. If water existed in the distant past on Mars, there's the possibility for ancient life on Mars. Did life start, not necessarily get a foothold, but get a beginning in the distant past on Mars? And this was written up in the July issue of 2020 Sky and Telescope. This is a picture, biosignatures. This is what we're looking for. The hunt for ancient life on Mars involves a search for biosignatures. Things like organics. All life on Earth is made of carbon-containing compounds, but they form in the absence of life. But Perseverance is the Mars 2020 rover. We'll talk about that in a minute. Perseverance will be able to tell if organics are present, but now which ones? Isotopes, another sign of life. So atoms of an element always contain the same number of protons, but can have differing numbers of neutrons. That's an isotope, of course. It's just a heavier atom. Certain biological processes prefer one isotope over another. So it's another fingerprint or earmark, if you will, of life. Minerals. Some minerals on Earth are uniquely associated with life. Perseverance can find these minerals, but only if they contain an abundance. Chemicals. Metabolic processes often have chemical signatures that's indicative of life. And then you have small scale and large scale structure. Now, on Earth, in near lakes, streams, ponds, we see structures called stromatolites. This is ancient microbial life on Earth that forms these mats, these layered structures, if you will. So that's really what's meant by large scale structure. Microbial life on Earth builds mats, stromatolites, reefs, and other large structures. Can we see evidence of that in some of the Martian samples? if life in fact did exist. We have no proof today that it ever existed on Mars, but we do have strong proof that there was once water on Mars. And where we had the water on Earth, we had the stromatolites. Did we have the same thing on Mars? Okay, so this is the Mars 2020 rover. And as you can see, it looks a lot like the Curiosity rover with some noticeable upgrades that are going to search for those organics or those microbials, biosignatures, I'm sorry. Specifically, I want to point out 7 different instruments that are unique to Perseverance. Now, what's new about the Perseverance rover is something called Raman spectroscopy. This is new technology for Mars 2020. And it's used in chemistry labs across the world for decades to analyze the fingerprints of molecules and allow sensitive detection of carbon-containing compounds, including ones of biological interest. So what Raman spectroscopy does is it uses a laser light shown on a sample to scatter that light and offer information about the molecular vibrations inside that material, which they then scientists use to interpret the sample's makeup. So the Mars 2020 rover, Perseverance, will have 2 Raman spectrometers, Sherlock and the SuperCam. We'll use this technology to literally fingerprint samples on the surface of Mars. SuperCam will dissect organic compounds from a distance, identifying the chemical and mineral makeup of targets as small as a pencil point from 7 meters away. Color imaging, visible and near-infrared spectroscopy are also available with the SuperCam. Now, the Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, uses a UV laser. This is on the arm of the rover. Uses a UV laser to map mineralogy and organic compounds. Microscopic imaging of Mars's surface. Though this will be more of the fine detail analysis of samples that the Mars 2020 rover deems as necessary or as viable to analyze. The M.A.S. cam is an advanced camera with panoramic and stereoscopic imaging and zoom. It's got a zoom capability to help select samples and characterize the geology and geological context of the landing site. Jim Bell, he's the lead investigator or the lead scientist on this team. The M.A.S. cam, an upgrade from what Curiosity had. Now, Pixel is also on the rover's arm, and this stands for Planetary Instrument for X-ray Lithochemistry, and this is an X-ray spectrometer and imager. It's a more detailed detection and analysis of chemical elements. It allows for a more detailed detection and chemical analysis of elements than ever before. So this is a significant upgrade on the Mars 2020 Perseverance rover that will allow scientists, again, to more finely determine the chemical makeup of elements on Mars. So both Sherlock and Pixel, of course, are cutting-edge instruments and are what these are what professional geologists on Earth utilize when hunting for signs of past life and ancient rocks here on Mars. So again, think of Perseverance as a robotic field geologist on the surface of Mars. RIMFAX, radar imager for Mars' subsurface experiment. And this is a ground-penetrating radar that will provide centimeter-scale resolution of the geologic structure of the subsurface. MEDA, Mars Environmental Dynamics Analyzer. This is a set of sensors that provide measurements of temperature, wind speed, and direction, and pressure, and dust size and shape. So this is essentially the meteorological component of the Mars 2020 rover. And then MOXIE. Now, if we ever send a colony to Mars, human beings to Mars, we will need an instrument like MOXIE on a larger scale to extract oxygen from the carbon dioxide atmosphere to be used either for fuel for a return trip to Earth or obviously for breathing. MOXIE is the prototype of that particular instrument. It stands for Mars Oxygen In Situ Resource Utilization Experiment. And the goal is to produce oxygen from the Martian carbon dioxide atmosphere. And again, if we ever send a future crewed mission to Mars, we will need something like MOXIE on a larger scale to support that crew. 7 instruments. Now, Mars 2020 Perseverance is not what Curiosity was. Curiosity was a Mars science laboratory. Its goal was to analyze samples internally right there on the surface. Perseverance is really the first leg in a much grander project to identify, gather, and cache samples for a future return to Earth. And one more thing. Now, to call it a helicopter is really to embellish it. It weighs 4 pounds. The size of the cube of the chassis is about 1/2 foot per side, 31 inches tall. But if successful, Ingenuity will be the first vehicle to fly in the atmosphere of another world. 5 test flights are planned, 3 minutes each over a period of 30 days. So look for this, Mars helicopter, Ingenuity, another innovation for the Mars 2020 mission. Now you're looking at a map of the topography of Mars, the color-coded for elevation. The blue areas are lower elevation, and then the whites and the reds are higher elevation. Mars, similar to the moon, has topology of highlands and lowlands. So primarily the highlands are in the southern hemisphere and the lowlands are in the northern hemisphere. Now, this map is a little deceptive because it seems to imply that there's water on the surface of Mars. Not true, of course, but if water did exist on Mars, it would actually pool in these areas. You can see Hellas Planitia here, and of course this is Gale Crater, which is where the Curiosity mission landed. Mars 2020, similar to Curiosity, will also land in a crater. In this case, Jezero Crater, which is thought to be an ancient lake where water formed, about 30 miles wide, that has a fan-shaped delta rich in clay minerals.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high and are the rim of Jezero crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars' climate changed, Lake Jezero dried up, and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
Every 26 months, Mars and Earth uniquely line up to create the opportunity to go. And you can see from this diagram here, Earth actually catching up to Mars in its orbit. Mars reaches opposition October of 2020 this year. And opposition, of course, is when a planet is on the opposite side of the sun from where the Earth is. Great time to view the planet. But now's the time to go. Between July 20 and the first week of August, that's the window to send spacecraft to Mars. And you can see the trajectory here. Essentially send it off and then catch up with Mars 7 months later. And you can see where Mars and Earth are going to be respectively in their orbits. Mars takes about 1.88 Earth years to orbit the sun. So now's the time to go. July 20 to the first week of August is the window. Now, as of the time of this broadcast, NASA is the only space agency to successfully land a rover on the surface of Mars. However, that all could potentially change. China is attempting to do something that no other space agency has done. Send an orbiter, a lander, and a rover to Mars in the same mission. And if successful, we could have another lander on the surface of Mars doing more science. Now, the orbiter has a hefty payload, 2 cameras and a spectrometer for surface mapping, a radar instrument for detecting subsurface water ice, and a magnetometer and particle analyzer for studying the space environment. The surface rover is 240 kilograms, about a quarter the mass of the Mars 2020 Perseverance rover. It carries ground-penetrating radar, a multispectral camera, weather instruments, and magnetic field instrument. Nominal mission time is 90 sols, or 90 Martian days. Also, the United Arab Emirates is launching its HOPE orbiter, not a lander on orbiter, but HOPE aims to monitor what's happening in the Martian atmosphere for a full local year, including making connections between layers of the atmosphere that will help scientists understand not only Martian weather, but also how Mars has lost some of its atmosphere over billions of years of planetary history. To accomplish that end, the 1,500 kilogram orbiter will carry 3 remote sensing instruments, a multiband camera, and infrared and ultraviolet spectrometers to a wide elliptical orbit, 14,000 miles by 27,000 miles around Mars. From this remote viewpoint, Mars will rotate more slowly under the orbiter, enabling the instruments to take long looks at the development and evolution of global weather patterns. For the United Arab Emirates, however, HOPE has a second set of worldly goals that are equally as important as the scientific ones. The mission is part of a long-term national effort to take the country from an oil-based economy to an expertise-based one. Again, the space program is only about 6 years old, 5 or 6 years old. The average age of its members is 27, and 80% are women. So this is really the UAE's step out of just being an oil-based economy, but also being a scientific-based one. There was a fourth mission planned for Mars, ExoMars, maybe the most interesting of all of them. Unfortunately, it's been delayed due to parachute problems, and it's too bad because this mission was actually going to drill about 2 meters into the Martian surface and look for samples of either water or microbial life below the surface. Mars, of course, has almost no atmosphere and no magnetic field, so radiation constantly bombards the surface unimpeded. So if there ever was any life on the surface, it would have been obliterated by radiation long ago. But maybe below the surface, we see the signs of ancient microbial life or water. So unfortunately, not going to happen this year, but in the year 2022, this mission may be launched. It's a joint effort by the European Space Agency and the Russian Roscosmos Agency. So 2022. As of this date, there are 6 operational orbiters around Mars. 3 of them are NASA, Mars Reconnaissance Orbiter, Mars Odyssey, almost 20 years functioning, definitely on borrowed time, as well as MAVEN. And then the India's Mars Orbiter mission and the ExoMars Trace Gas Orbiter but from the European Space Agency. And there are 2 operational landers. We talked about the Mars Science Laboratory, Curiosity. Mars InSight landed in November of 2018. It's doing Martian seismology to analyze the tectonic activity and the meteorite impacts on the surface of Mars. So these 6 landers, or these 6 orbiters and these 2 landers are potentially about to have some company if all 3 of these missions are successful. 2 more landers, 2 more orbiters, 3 different countries. Now, success is anything but assured. In the 50-plus years of the history of exploration of Mars, the 42 missions that have been sent to the Red Planet, only 43% have failed and only 38% have succeeded. 19% were partial successes. They don't call it the Martian Ghoul for nothing. Very high failure rate. So success is less than 50%. And we certainly hope that, no pun intended, but we certainly hope that the 3 missions that are going will in fact be successful and enhance our understanding of the Red Planet. I will end tonight's broadcast with this. Mariner 4 went to Mars in 1965. It's the first flyby mission. It was our first glimpse at what the surface of Mars truly looks like. Now at that time, transmission and data speeds were primitive at best compared to today's standards. So Mariner 4 literally transmitted back data of the images it was taken in the forms of 1s and 0s that were printed out on a sheet of paper, and then scientists literally cut that sheet of paper into strips and pasted them on a wall like you see here, and then used coloring pens to color in the shades of the different colors corresponding to the data that was sent back from Mariner 4. So this is our first ever image of the surface of Mars. It's an extraordinary story. There's a full YouTube documentary on Mariner 4. I would encourage you to watch it. It's extraordinary. But in a little over 50 years, thanks to other missions that have gone to Mars, Pathfinder, Sojourner, Curiosity, Spirit, Opportunity, we can not only see what it's like to be on the surface of Mars, but feel what it would be like to stand on the surface of Mars. Thanks to YouTube channels like this one, Mars 360. Our understanding of the Red Planet has grown by leaps and bounds, thanks to the tireless work and the countless hours of effort put forth by scientists at NASA, JPL, students and professors in universities around the country and around the world. This is truly a collaborative international effort in the scientific community to enhance our understanding of other planets like Mars. So, and in fact, a lot of the technology that's going to be on board the Mars 2020 rover was developed in other countries, Norway, France, Spain. So this truly is an international collaborative effort. So I would like to end tonight's broadcast with a video tribute to 50 years of Martian exploration. This is available on YouTube, and it's also available on the Mars 2020 Perseverance website. Feel free to check it out. Reminder, if you haven't already, the links to the July sky map and our membership application are going to be in the description below, so feel free to download those. If you'd like to be on our email list, go to the website joinmas.com, enter your name and your email address. And also, if you want to send us an email, Memphis Astronomical Society at gmail.com. So, signing off, I'm going to stay on for the live portion of this broadcast for a little bit longer. If you have any questions or any comments, please feel free to enter them into the chat room. We'd love to hear your feedback. Thank you again for joining us, and Godspeed to all the scientists at NASA, JPL, the European Space Agency, the UAE, as well as organizations around the world. Perhaps the advancement of science is the one thing that's unifying us in today's world. So we look forward to some exciting discoveries to come as this 2020 year continues to unfold. Thank you very much.
Hey, there we go. There she goes. Yeah, that's data.
There is some sort of a hacker to the data, and we have now full confidence that this does indeed correspond to a photograph of Mars.
Based on your preliminary analysis of this data, can you describe what you see on Mars?
Yes, it's there.
Standing back for touchdown.
Led by the extraordinary men and women of NASA and our Jet Propulsion Laboratory. Right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity will stand as an American point of pride far into the future.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.